Hello everyone, I am Anusha BM from Shivenkeshwara College of Engineering, Bangalore, USN 1BE 23EC009, Semester 3, Section Astros, Course Network Analysis, Course Code BEC 304. Topic. Now I am going to give small presentation about this topic. Classification of electrical networks. Introduction to electrical networks. Electrical networks are interconnected components that allow the flow of electrical energy. They can range from simple circuits with a few elements to complex systems with numerous components. They are essential for the distribution and control of electrical energy. Understanding their classification helps in analyzing the behavior and design. An electrical network is a collection of electrical components like batteries, resistor, capacitor, and inductors that are connected together. Definition of electrical networks. An electrical network consists of elements like resistors, capacitors, and inductors. They can be interconnected in various configurations. These configurations determine the network's functionality and performance. An electrical network differs from an electrical circuit in that an electrical circuit requires all connections to be closed, while an electrical network can have open paths. Types of electrical networks. Electrical networks can be classified into two main parts, linear and non-linear. Linear networks obey the principle of superposition and have constant parameters. Non-linear networks exhibit behavior that varies with the voltage or current levels. Electrical networks are classified into four types based on presence of source, based on direction of current, based on separability, based on linearity. Based on presence of source classified into two types active and passive. Based on direction of current classified into two types bilateral and unilateral. Based on separability classified into two lamped and distributed. Based on linearity linear and non-linear. Linear electrical networks. Linear networks consist of elements whose voltage and current relations are linear. Common examples include resistive circuits and RLC circuits under small signal conditions. There are erasers to analyze using techniques like superposition and Thales theorem. Linear network is a network that exhibits constant parameters, this resistance and inductance. Non-linear electrical networks. Non-linear networks contains elements like diodes and transistors. Their behavior is not proportional to the input voltage and current. Analyzing non-linear network obtained requires numerical methods or simulations. It consists of at least no one linear element to not connecting the voltage and current independent source. Active electrical network. An active network contains at least one voltage source or current source that can supply energy to the network independently. Active components is defined as an electronic component that supplies energy to a circuit and can control electron flow. An electron circuit must contain at least one active component. Passive electronic network. Passive network is an electronic component which an one only receive energy, which it can either dissipate, absorb or store it in electric field or magnetic field. Passive elements do not need any form of electrical power to operate. As the name of passive suggests, passive devices do not provide gain or amplification. Passive components cannot amplify, oscillate, or generate an electrical signal. Series electrical network. Components connected in series are connected along a signal electrical path and each component has the same electrical current through it. It equal to the current through the network. The voltage across the network is equal to the sum of voltages across each component. The series circuit is a circuit where the components are connected end to end in a line as illustrated in the figure 1. Parallel electrical network. If two or more components are connected in parallel, they have the same difference of potential voltage across their ends. The potential difference across the component are the same in magnitude, and they also have identical polarities. The same voltage is applied to all circuits components connected in parallel. Series networks characteristics. Series networks have a single pathway for current flow. The total resistance is the sum of individual resistance. Voltage is divided among the components based on their resistance. Parallel network characteristics. Parallel network provide multiple pathways for current flow. The total conductance is the sum of individual conductance. Can is the divided among the components based on their resistance. Here is the example resistors in parallel. R3, R2, R1 are connected in the parallel. Time invariant versus time varying networks. Time invariant networks maintain their properties over time. Time varying networks have components whose characters change with time. This classification is important for understanding signal processing and communications. This is the example. This is the input signal x t into t naught. This is the system t. Output signal y t to t naught. In ideal versus real networks, ideal networks assumes perfect components with no losses. Real networks can account was partially factors such as resistance, capacitance and inductance. This distinction are critical for accurate modeling and simulations. This was the example. There was ideal and partially versus electrical networks theorem. Various theorems assist in analyzing electrical networks. Key theorems include Thevenin's, Newton's and superposition theorem. These tools supply complex networks into manageable forms. This was the example for voltage source in 1, voltage source in 2. Applications of network theory. Electrical network classification are crucial in circuit design and analysis. They help engineers optimize performance and efficiency. Applications include power system, communication networks, and electronic devices. Software tools for network analysis. Several software tools assist the simulation and analysis of electrical network. Example include SPICE, MATLAB, and PS. These tools provide visualization and help predict network behavior. This was the example. Future trends in electrical networks. This rise of smart grids in charging of electrical networks are classified and utilized. Renewable energy sources are influencing network design and classification. Understanding these trends is essential for future electrical engineering practice. Thank you.